Alright, so this video is going to teach you how to do a vertical T-joint with 70/18s, and it could be applied to 60/13s too. They kind of carry pretty similar. We're using a 1/8 inch rod, and we're running this at about 120, 125 amps. You really want to run these as hot as you can. If you can get it as hot as 135, it's not going to hurt you. This is only 1/4 inch thick plate. It can be done at that temperature. You're going to have some problems just at the ends of the weld, but for the most part this will work at 120 amps. It's pretty comfortable. There's two techniques I'm going to show you with this one. One of them is a side-to-side technique. It's just working the corners. So pause at the side, go to the center, pause at the side, go to the center, pause at the side. And this works real good. It ties the base metal in nicely, gives you good control of the arc. You don't have any drips that way. The pausing at the sides of the weld really helps control any kind of runs that you might end up with. If you just try running straight up, you have to carry a real fast travel speed, and you can risk the fusion and penetration that you would get by using this technique, by using the side to side. So this is just done. You hold your corners. Okay, I say that all the time. Cross the center quickly, and the reason we follow the contour of the plate is so we don't long arc as we cross. So we hold the side, we push it in, cross to the other side, and the weld usually looks pretty good. You'll notice if you look at the top edge of that weld, you can see the base metal is cut in nice and deep, so we got good penetration. If your travel speed is proper, you get good fusion, and it works real good. You're basically just kind of building on top of a vertical shelf. This technique is the step technique, or a stepping motion, not a whip. It's just a slight step. I do this for overhead. I like it in T-joints. It's kind of like a safety technique. It always works. It's really simple. It's done at the same amperage, and you just start at a spot, hold it for a second, step up a little bit, maybe 1/8 of an inch, 1/16 of an inch, somewhere in there, and just work your way up the plate that way. The results are almost identical. If you compare the two welds after we chip the slag off here, you can't even tell a difference. Aside from a little bit of spatter, which is from a long arc that I made right about that spot. But the two welds are identical. They produce the same size weld if you're looking for, if size is an issue, if you're working to a welding code. And if you're just building a trailer or something like that, any kind of structural steel member, it works real good. If you're working on thicker material and you need extra material or extra weld metal, say on 1/2 inch, you want to come up with a 1/2 inch size weld, so you have your minimum fillet weld size. You can weave over this, and again, the best way to do this, I prefer weave beads over stringer beads on this joint, especially vertical. The best way to do this is the same technique we use for the root pass, the first weld that I showed you, which is the side-to-side motion. You're just going to hold your corners, cross the center quickly, get to the left side, cross the center quickly, hold the right side, cross quickly, hold the left side, and this allows you to come up with a flat weld. Now you'll notice in this particular segment that my stepping up, my crossing is a pretty steep angle, and I kind of did this to show you how to sculpt your welds a little bit. When we chip the slag off of this weld, you're going to see very distinct ripples where I crossed, and this is something that you want to try to avoid. I'm going to show you in the second half. I kept it much tighter, and you're going to actually be able to see a difference in the weld appearance. It's not going to hurt you in weld quality so much, but more in appearance. So if you compare the last one, it's a microscopic difference, but if you compare it, you'll see I'm moving quicker. I'm not holding the sides as long. So I'm sweeping the bottom edge kind of, we'll call it tighter. It's a lot tighter of upper progression. And when we show the weld at the end, you'll be able to see, the real difference between this. So if you're having trouble, and your welds look like they're very sloppy, you're stacked unevenly, try tightening it up with this technique. Just, upward progression, very slow. Another way to eliminate that kind of issue also is turn the heat up. The hotter you run it, the better the tie-in you get as you cross. And if you did it right, your slag should be dripping right down the center. Alright, so here's a close-up of the first weld where we made a quick upward progression, a very heavy angle as we worked our way up the plate, and you can see the ripples in that weld are not as pretty. If we look at the second half of the weld, where we kept it tighter, particularly down at the bottom end there, you can see that it's real tight. Looks like one solid piece, one nice solid weld. So keep that in mind as you're doing second passes on this, or any weld that you're holding your corners. This is especially good practice for doing, for practicing for a structural steel test. You can throw another weave bead or 2 or 3 on top of that if you wanted. But for the basic T-joint, that's going to work just fine. Either hold your corners or use the stepping motion, and watch your weld size. Make sure it's relevant to your metal thickness. I hope that helped you guys out, and good luck.